Right. So for today then, chapter 5. So if we look in terms of an X and Y coordinate system, we can break it out into quadrants. So this would be 1, this is quadrant 2, this is quadrant 3, and that would be quadrant 4. In terms of angles, we have that if you go in this direction, this is the positive direction. And if you go this way, this would be the negative direction. So if I work my way around the quadrants in terms of degrees, you got that this is going to be 0. This will be 90, maybe. This is 180. This is 270. And then all the way around is 360 degrees. Well, in terms of angles, we can measure angles in degrees. You can also measure angles in terms of radians. Okay. So in regards to radians, and let's redo this. So 0, 90, 180, 270, 360. Well, 0 degrees is going to be 0 radians. 180 degrees is going to be pi radians. So if 0 is 0, 180 is pi, what would 90 degrees be?
2 pi.
Half a pi for 90.
Oh, 90. I thought you said 360.
No, got to answer my questions, not the one you hear in your head.
Okay. That's what I thought.
All right. All right, so now, Nathan, if 0 is 0, 180 is pi, what would 360 be?
2 pi.
Very good. Okay. All right.
What's that up by 90?
Pi over 2. Okay. All right. So if 180 is pi, 360 is 2 pi, what will 270 be? What? Pi and a half. And the way we write that is 3 pi over 2. Okay. So that one of the things you should be able to do is convert back and forth between degrees and radians. And so in order to do that, we need to have a conversion factor for this. And the conversion factor we're going to use will be that 180 degrees is equal to pi radians. That's our conversion factor. 180 is pi, right? So, for example, if I want to convert 30 degrees into the corresponding radian measure. So we got 30 is to 180 as x is to pi.
Where did that 30 come from?
That's the number that popped in my head at the moment. we're going to convert 30 degrees into the corresponding radian measure. Right? So convert 30 degrees into radians. Right? Well, the way you solve a proportion is always the same. You cross multiply and divide. So if I do that, we get x is going to be 30 pi over 180. And generally, radian measurements will be left in terms of pi. So really, we need to look at the numbers part of it and simplify my fraction. What number goes into both 30 and 180? 6? 5? Or we can go larger and let's go with 30 goes into both. Right? So 30 goes into 31, so this will give us pi. 30 goes into 180 6 times, and so 30 degrees is going to be pi over 6 radians. Right?
If you cross multiply, how come you don't end up with like 180x?
Yeah.
Well, you cross
Yeah,
multiply and
180x
divide.
equals 30 pi.
Oh, okay.
And
Gotcha.
then
The whole process is you cross multiply divide, right?
Okay, I got it now.
This is the way you solve a proportion.
Good.
Cross multiply divide by the number, right?
Mm-hmm.
Right? So 30 degrees is the same thing as pi over 6 radians. Right? Right? So then, for example, do this. Convert 315 degrees into the corresponding radian measurement. Take a moment. That leaves these out the same way as the last one I did. Take the 30 out, plug the 315 in that spot. And do it. So that's your proportion. Again, cross multiply divide. That's how you solve a proportion. So x will be 315 times pi. And now the next part is simplify that fraction. What do we get?
So you do 315 times pi and then that number divided by 180?
Yes.
Okay.
So 315 over 180 becomes what?
7 over 4.
Will become 7 pi over 4.
Yeah, I didn't get that.
All right. So again, you've got to reduce this number part. So I need a number that goes into 315 and 180. Okay, we could go bigger than 3. 5, all right. So you can tell right away by looking at that number, those numbers, that 5 will go into both, right?
Yeah.
That's easy. If it ends in 5, it ends with a 0, it can be divided by 5. Okay? I can also tell right away by looking at those two numbers that 9 will go in both. Right, Nathan? Sure. It's easy.
I keep getting 5.4.
So what do you do at that step, the 3?
We need to reduce the fraction. So again, you need a number that goes in the top and bottom.
But you're sort of ignoring pi for that.
Oh.
Right, I don't worry about the pi.
Yeah.
Okay.
What?
45.
45 is the biggest number that goes in the book. It is correct.
Pi is just.
Now, you could do it by steps and work your way to the number. You could do 3s and then keep on reducing until you can't, and then you go to another number. But again, I can tell by looking at this 5 goes into both. I can also tell by looking at the numbers that 9 goes into both. Right, David?
Yep.
How come?
Because
Because I said so, right?
Because they both end in 5 or 0, and because they both, their digits both add up to 9.
Right. So the test for 9s is fairly simple. If the sum of the digits is a multiple of 9, the number can be divided by 9. So what is 3 plus 1 plus 5?
Is it 9?
It is 9. What is 1 plus 8 plus 0?
Is it also 9?
-7.
Right? And now, I also know right away that 45 can go into both. Because 5 goes in there, 9 goes in there. 9 is not a multiple of 5, therefore 45 also goes into both numbers. So we end up with 7 pi over 4. Right?
So you don't even have to worry about the pi at that
No.
point?
And generally, radian measurements are going to be left in terms of pi. Okay? Unless they say round the answer to the nearest whatever, but that's the exact answer.
Okay.
Because after all, pi is a number that goes on forever and ever and ever, right? Right? So, given an angle in degrees, you ought to be able to convert it into the corresponding radian measure, which means that also, given an angle in radians, you ought to be able to convert it into degrees, right? So, for example, I want to convert (3 pi over 5) into degrees. Well, again, our conversion factor was pi is 180. So I get 3 pi over 5 divided by pi is going to be x over 180. Okay?
So whenever you're using pi, 180 is your base?
Yeah.
Okay.
Pi radians is 180.
Okay.
Okay? And if you wanted, you could use, 270 degrees is 3 pi over 2. But
Nothing.
it's like when we talk about converting between inches and feet and all that stuff, we use that 1 foot is 12 inches. You could use that 3 feet is 36 inches to do your conversions, but we don't do it, all right? Yes?
Is that 3 pi over 5? Is that just an example?
I'm going to do this for my example.
Okay.
All right, so here's my proportion. Well, the thing about this one is that the left side simplifies quite nicely because 3 pi over 5 divided by pi will become that. The pi's go away. Let's see. So this is a nice simple proportion. Again, cross multiply divide. So x is going to be 3 times 180 divided by 5, and that you can plug into the toy and get a number. And you plug that in, you end up at
108.
108 degrees. Okay. Okay.
So what if the pies don't cancel each other?
They do cancel each other.
Well, like in a different equation, or would they always cancel each other?
We're always going to cancel each other.
Because you're divided by pi. Gotcha.
Okay? Now, the reason why they cancel each other, let's go back up. Why do they cancel? You got 3 pi over 5 divided by pi, right?
Yep.
And how do you divide fractions? You leave the first one the way it was, change the sign to multiplication, flip the other one over, and so you got a pi on top, pi on bottom, they go away.
Gotcha.
So the pi's will always go away.
Okay.
Right? So, right. So we can convert between degrees and radians, right? So in terms of angle measurements, right? So that is 30 degrees there, right? What would that measurement be?
330.
Huh?
330.
Not 330, but
Negative 330.
negative 330, right? So going in this direction is positive. Going this direction is negative. So this would be negative 330 degrees. Right? So 30 degrees and negative 330 degrees get you to exactly the same spot. Right? They are coterminal. You end up at the same spot. Right? Yeah. So 30, I could also do okay, 30 degrees, 390 degrees, 750 degrees, all get you exactly to the same spot. Okay.
You do the same thing with negatives.
Right.
Negative 660.
Right. Right, Nathaniel?
Oh.
Right? So here's 30 degrees, right? From here to here is 30,
Yeah.
right? Well, what would 390 be? So we start here, go all the way around. That's 360.
Okay.
Go another 30 more. I'm there.
Gotcha.
750 is around once, around twice, back to there, right?
Got it.
All right. I could also do the same thing in the negative direction. We go negative 330. What would be the next one?
Negative 690.
Negative 690. Okay? After all the way around is 360 degrees. Yes?
Wait, why is that second one negative 690?
Because what's all the way around a circle?
360?
Right. You go 360 degrees, you end up back where you were.
So 390 plus, 360 plus 390 is 60.
Now we're going the other direction, so negative.
Yeah.
Okay. Okay, now we're going the opposite direction. So we're going,
Negative 360.
Negative 360.
Minus 360.
but negative 360, positive 360, it really doesn't matter. You still end up the same. Right? It's increments of 360. Right? So all of those angles are coterminal. Right? They're all coterminal with my 30-degree measurement. Right? Well, it's easy when it's degrees, because degrees are nice, right? You're used to degrees. 360 degrees all the way around a circle. Right? What happens if I now say this was pi over 6? Now, what is that measurement? Again, degrees is easy. Radians, different matter. Okay? Well, all the way around a circle is how much?
360.
But how about in radians? How far is all the way around a circle?
2 pi.
2 pi, right. So, this number is going to be 2 pi minus pi over 6. Well, in order to add or subtract fractions, you must have a common denominator,
So 12 pi.
which will be, in this case, 6. So 2 pi, I can rewrite as 12 pi over 6. So 12 pi over 6 minus 1 pi over 6 will give us
11 pi.
11 pi
It's
over
going to
6.
be negative because it's going backwards.
So this is going to be a negative 11 pi over 6. Okay. Again, you go one way, it's the positive direction. You go the other way, it's the negative direction. Okay?
Who
All right.
decided to make this opposite of clockwise and counterclockwise?
Yeah.
Who is in charge of that?
Who's in charge of
Is that a
that?
working group or what? Because that's going to make it really. I'm going to keep messing up with that, I bet.
Well, it could be worse. We could have our Celsius thermometers run the opposite direction, which is what he first set it up as. He actually labeled them the other way. All right. So in terms of pi over 6 then. Right. So the first one is pi over 6. Right. In terms of positive measurements, my next one is going to be 13 pi over 6.
So how'd you get that 12 pi again?
Because I can rewrite it, I need a common denominator. After all, this is over 1, right? So the common denominator is going to be 6, right? Well, 1 times 6 is 6. 6 times 2 is 12. Yeah.
So by getting that 13 pi 6, you're just going from where you started at the pi over 6.
And adding 2 pi. 2
So you're ending
pi.
back up at the same place,
Right.
but just one more rotation.
Right. Because given that my denominator was 6, right? Right here, this 2 pi is that, right? So all I gotta do is add multiples of that. So my next one is 13 pi over 6. What's the next one after that?
14.
25 pi over 6.
What?
25 pi.
25. You got 13 pi over 6 plus 12 pi over 6.
So negative
Oh.
would be minus 23 pi over 6 from the minus 11.
Right? We got to add all the way around the circle again, right?
Wait, so you always use the number that is the,
The one you used before.
okay, no.
Okay. My next one will be 25 pi over 6. Because all the way around is 12 pi over 6.
Oh, okay, so you just add 12.
Go around again. Now what am I at?
37 pi.
37 pi over 6.
So the negative is negative 23 pi over 6.
So in order to be able to do that, we have to first have a common denominator.
Right. Again, in order to add or subtract fractions, though, that rule hasn't changed any. Okay? Still the same rule. Okay? All right? So 37 pi over 6. So now you go in the negative direction. All right? So if I go the negative direction, we said this was 11 pi, negative 11 pi over 6 for the first one. All right? So in terms of negative direction, the first one was this. What's the next one going to be?
Negative 23 pi over 6.
23 pi. That's the next one. Right, Haley? What's the next one going to be, Haley?
Negative 35 pi over 6.
Is that an answer or is that a question?
That was the answer.
Okay, it didn't sound like it, but that's okay. But you are correct. And they are all coterminal. They all get you to exactly the same spot. Okay? So whether it's in degrees or whether it's in radians, okay, it's easier in degrees because that's just adding plus or minus 360. That's easy. Okay? But you should also be able to do it in terms of radian measure.
And this is radian measure right here.
Yeah, if it's got the pi, it's radians, right? After all, one way to know if the angle is in degree measurement is it should have that little degree symbol in the upper right. Right? Well, in terms of radians and radian measures, everybody has seen a formula regarding a circle. That actually has part of its equation. It is talking about an angle in radians. What is the formula for circumference of a circle?
Pi over
2 pi
2 pi r.
What?
2 pi r.
2 pi r. What is circumference?
The distance around the circle.
It's the distance around the outside of a circle, right? It's basically it's the perimeter. Right? It's just that for a circle we call it circumference. Well, what does the 2 pi represent?
The radian.
Time to go around that. Not time, but
2 pi
one-
represents
one
that you
complete
went
rotation.
all the way around the circle. 2 pi is 2 pi radians. It's all the way around. Okay? That's what that represents. Okay? So you get in terms of
My brain just melted.
arc length. The circumference is a special arc length. It's the arc length when you go all the way around the circle. Okay? But if I look in terms of, I have a circle of some radius r. My central angle is here, which will be theta. And then the arc length will be this measurement right here. And the designation for that is S. And the formula then is that S is equal to R times theta. This number must be in radians. So if the angle was given in degrees, the first step would be to convert that into radians and then find the arc length.
Wait, what?
But if the angle is given in degrees, you must first convert into radians and then calculate. So, for example, if R equals 5 feet, theta is equal to 3 pi over 5 radians. What is the arc length? Now, given that I gave you the angle in radians, we don't have to convert, right? So it's a matter of multiplying R times theta. And so S is going to equal 5 times 3 pi over 5. Okay. So as a matter of plugging that into the TOA, you end up with 3 pi, and you're going to end up on the order of 9.42 and change.
Oh, so since this is a length and not a radian, you actually multiply against pi now.
Yeah, depending if they want the exact answer or if they say round it to the nearest whatever.
So 9.4 something.
So we turn pi into blue.
No, you got a pi key on that thing. Pi key.
Wait, so but this number is supposed to be in radians, right?
It is in radians. I gave you the angle in radians.
Theta's in radians.
That's so that S doesn't have to be. The
No, S will be a number.
and it's
But
gonna
the
be-
theta has to be in radians. The angle must be in radians.
S is going to be in whatever measure that.
All right?
that
So if you do this out,
R is.
again, your calculator should have a pi key, right?
Okay.
Right? You end up, you plug that in the toy, and you end up at.
9.4.
And so the units on this
That's what I was gonna ask.
will match the units on your radius. So the arc length will be 9.42 feet. Okay? It will match whatever the units were on the radius of your circle. Okay?
Let's do one that's not in radians.
Let's do one that's not. All right. All right. So.
Damn it, Haley, that's madness.
So, all right. Find S. If R is equal to 6 meters, theta is equal to 72 degrees. Huh? And get that answer to the nearest hundredth. And that would be in terms of meters.
So because it's in degrees, we're not using pi, right?
No, because it is in degrees, because Haley asked for it,
Right.
you got to first convert into radians.
Oh, we got to convert the 72.
Again, if the angle must be in radians. If it's not in radians,
So find the circumference.
find the arc length.
Arc length, gotcha.
Again, circumference is a special arc length.
I have like a 50-50 sense of security of having done this right.
So to the nearest hundredth, and we got a number. What do you get?
7.54.
Yeah, 7.54.
7.54 would be correct. Right? Huh?
Yeah, I don't know.
Right. Right. So 72 is to 180 as x is to pi. Solve that for x, cross multiply, divide. Right? That's my angle. Now, if I want, I really don't even care what this number is. It's not, I really don't need to know what it is as far as the step. I could say that S is going to equal 6 times 72 pi over 180. I can do that. So all you got to do is go 6 times 72 times pi divided by 180. I don't care what that decimal number was. Right? And you end up at 7.54. And that will be in meters. Right? Right? So now the next question is, what is the area? How big is this area? Well, the area then is given by 1/2 r, well, 1/2 theta r squared. And again, theta must be in radians. Right? So if I want to know what is the area of that piece, I got that the area is going to equal 1/2, which is 0.5, times 72 pi over 180 times 6 squared.
Can you go back up to the
Formula?
yeah?
1/2 theta r squared.
Are you squaring it because of the diameter?
No. That's the formula.
Oh, I didn't see that.
So when you're converting it into radians, the 180, is that
Always.
always going to be, it's always going to be over 180?
Right.
Wait, so you can't do, wait, okay. You can't do 2 pi over 5, that has to be.
You could.
You could?
Oh, if you simplify it, you could. Like I said, I don't really care about simplifying. I don't really need to know what a simplified is in this
So you
case.
don't need to have it over, like, it's over 180.
You could, right. You don't have to have it over 180 if you decide not to do it that way. Right? If you decide to simplify that thing out, that's fine too. But again, as far as do I have to in this case? No, because I'm not. It's just a step, right? So the next thing then is to calculate this out, and that'll give you the area of that.
Did we say how we got the 0.5?
It's part of the formula.
Oh, okay, gotcha. Oh yeah, okay, half. Gotcha.
This is all multiplication really, so it doesn't matter what order we do this in, does it? I mean, 1 over 2 times 2 pi over 5 times 6 over 1 and then squared.
And the answer is
14.21. No?
22.
We got 22.61.
22.62.
Yeah.
Okay.
So is the 6, let's do the squared first.
So this will be 22.62, and the units here will be meters squared. Again, area is always in terms of square units, whatever those may be. Well, in terms of a disk that is turning, we can talk in terms of its linear speed and in terms of its angular speed. So if you think back to the good old days of going to the local neighborhood playground, before we decided to make everything nice and safe, you used to have the turning disc of death. So you got, in terms of the disc, you had the poles on the outside. You ran around and tried to make this thing go as fast as you could in order to make the kid that was on the edge fly off, right? Right? So if this thing is turning like this, right? And we got a person at point A, we got a person at point B, we got a person at point C, which one is traveling at the greater velocity? C, right? The further away you are from the center, the faster you are going. Right? Everybody is turning at the same angular velocity, right? So you got angular velocity, you got linear velocity. So angular velocity is given by the angle divided by the time.
Is that a W?
It's a script W. Yes, it is a survey W. Okay?
And that's angular velocity.
That's angular velocity. Now, depending on what you want, it could be in whatever, really, it could be degrees per second, degrees per hour, it could be radians per second, or so on, okay? In science, angular velocity is taken to be in terms of radians per second for the units, right? So you think in terms of something like the Space Needle restaurant, which basically makes one revolution about every hour. It's a little less than an hour, okay? In terms of how fast that thing turns. Okay? Right. Now, if we decide to crank that thing up a bit, instead of making one revolution every hour, we decide to make one revolution every minute.
It'd be much harder to work there.
Yeah, it'd be much harder to keep dinner down too.
Taking food from the kitchen.
Okay. Now we have to put little sunken platforms that the dishes would go in, right? So then they'll flying across the. Okay. Right. Right. So we got angular velocity. We can also look in terms of linear velocity. And linear velocity is given by v is equal to s over t. S being the arc length, which we had before. Okay. So you think about velocity. Velocity is distance over time. Our s is a distance. Right? Okay. And so where s was equal to r times theta, okay? Again, we had that earlier. Okay. Which means I could also say that v is equal to r theta over t. Okay. All I did was substitute. I took the s out, I put the r theta in, and we also have from earlier that theta over t is the angular velocity, and so we get that v is also going to be given by that. Right?
What is that? V is r times.
R times the angular w, the angular velocity.
Oh.
Because theta over t is angular velocity. So again, all I did was substitute. Right? So, for example, something like this. Right? We got that? So, determine the linear velocity given r equals 3 feet and the angular velocity is equal to 4 radians per second. And I want the answer in terms of RPM. We know what RPM stands for, right?
Revolutions per minute.
Very good. All right. So, linear velocity. Linear velocity is given by r times omega. V equals, so 3 times 4. Well, that's hard. That's hard, right? Are we going to be able to do that without plugging it into the calculator?
Hang on. It says 12, but I'm not sure.
Just double checking.
Okay. So this comes out to be 12, okay? And this will be 12 feet per second, and in terms of units. Because radians is actually a dimensionless quantity. It means, really, radians means nothing. Right? But my answer I want is in terms of revolutions per minute. Well, this is 12 feet per second. So I need to convert. So first off, how many seconds are there in a minute? 60. So we have that 1 minute is 60 seconds. That'll take care of the seconds, so those will go away. Second on the bottom, second on the top. They will cancel. Now, revolution. 1 revolution is equal to what?
360.
So what is the formula for
2 pi.
circumference of a circle?
2 pi r.
2 pi r, right? So 1 revolution is going to equal 2 times pi, maybe, and my r was 3. So I'm going to have
Wait, that's 1 revolution divided by 2 pi?
1 revolution is 2 pi r.
So we got rid of the 60.
Now we got rid of the seconds.
Oh yeah. We got
Alright.
rid of the seconds. But then where did the 60 go then?
No, the 60 we're going to multiply by.
Okay.
We're just looking at
Oh,
units.
is that-
This is going to be in feet, the units here. And so if I look at my units, this goes, this goes, this goes, this goes. I'm left with revolutions per minute. Because 1 revolution is equal to the circumference of your circle. So we end up with 12 times 60 divided by 6 pi. And to the nearest number here, this will come out to be 38.2 r.
So you do 12 times 60,
Uh-huh.
yeah,
Yeah.
and then,
Times 1.
Well,
And then over 2 pi.
so on your toy, do it this way.
yeah.
Whatever you got in there, clear it out.
No, okay, I get it. But,
All right. Should end up at 38.2. Is that what you got?
so whatever you get in seconds, you always just multiply it by,
If I want revolutions per minute, yes.
yeah, and then just multiply by 60 over
Right.
over the equation for circumference.
Because 1 revolution is equal to the circumference of the circle. Okay?
So 38.2 RPMs
Right.
is a linear velocity.
In terms of revolutions per minute, yes. Again, depending on how they ask the question. Okay? And you'll see one like that in homework, you'll see one like that on my worksheet. Okay?
Oh, okay.
Right? RPMs.
So you did 12 times 60 over 2 pi?
Yeah, 2 pi times 3.
Over 2 times, okay.
2 pi r.
So that's your revolution. That first part of the equation is the top
Is
part.
my velocity, my linear velocity.
Okay,
But then I want to convert that number because it said one the answer in terms of RPMs.
yeah.
So I need to convert feet per second into revolutions per minute.
Mhm.
So to do that, I got now 1 minute is 60 seconds,
Mhm.
and 1 revolution is given by 2 pi r. That gives me my conversion from 1 unit to the other. Okay? All right. So if I have a right triangle, the angles are labeled in terms of the capital letters, and then the sides, side A is going to be opposite angle A, side B is opposite angle B, side C is opposite angle C. And of course, given a right triangle, there should be at least one formula that everybody knows regarding a right triangle, and that is the good old Pythagorean
A squared plus A squared plus B squared.
equals C squared, right? Right? All right. So, given this triangle, we can talk about the trig function. Sine of A is given by the opposite side over the hypotenuse. Right? So relative to A, the opposite side is side A. The hypotenuse is always the side opposite the right angle. So my sine of A is going to be A over C. Okay. Cosine is going to be adjacent over hypotenuse. Relative to this angle, this is the adjacent side. So this is going to be B over C. Okay.
Let's say OPP.
OPP, opposite.
Okay.
Yeah, you know.
Okay. And then tangent is going to be opposite over adjacent, which in this case will be A over B. Those are the three main trig functions: sine, cosine, and tangent. Okay. Those are the ones you have buttons for on the toy. SIN, COSTAN. Right? Right. Now, however, along with these three, there actually are another set of three. And those three are just the reciprocals of the first three. So you also have the cosecant of A, which will be hypotenuse over opposite, which is going to be C over A. So sine and cosecant are reciprocals of each other. You have secant, which is going to be hypotenuse over adjacent, which is going to be C over B. And so cosine and secant are reciprocals of each other. And then you have cotangent, which is going to be adjacent over opposite, which will be B over A. And those are the six.
What's that last one? COT?
Yep, cotangent. Right. Okay. Okay. So those are the trig functions. So for example then, if I have a triangle, here's my right angle, this is 3, this is 4, this is 5, this is my generic angle theta. And I want to know what is sine, cosine, tangent, cosecant, secant, and cotangent of theta. Really, I want to know what are those fractions. Okay. So sine theta is going to be opposite over hypotenuse, 3/5. Cosine theta, adjacent over hypotenuse, 4/5. Tangent, opposite over adjacent, 3/4. The other three are just reciprocals of the first root. So, cosecant, 5/3. Secant, 5/4. Cotangent, 4/3. Once you know the first three, the other three are easy. They're just reciprocals. Okay? All right. So, given a triangle, you ought to be able to write out all the various fractions for all the. Okay. Well, in terms of my trig functions, again, I have a circle. And I have a point on the circle. Here's my point on the circle. The coordinates of that point are going to be given by x and y, whatever they may be.
See you next week.
Yep. Invisible ink. There we go. We'll go there. All right? Okay, we'll go inside. We don't like me going outside, so we'll go there. All right. Well, I can make a triangle, okay? I can go to that draw from here to here. That'll be R. I can drop this straight down, right? The distance from here to here will be given by the x-coordinate, whatever it was, right? The distance from here to here will be given by the y-coordinate, right? And so now I can rewrite my trig functions again in that sine theta is going to equal y over r. Cosine theta is going to equal x over r. Tangent is going to equal y over x. And so then cosecant is going to equal r over y. Secant is going to equal r over x. And then cotangent is going to equal x over y. Same thing as what we had earlier, except we're written now in terms of x's and y's and r's. Okay? Right? Now, given that a circle, in order to be a circle, must have a positive radius, right? R has to be positive. How many circles do you know of that have a negative radius? Right? So, given that R has to be positive, right? Almost caught up, Casey?
Yeah.
All right. So, given that R has to be positive, quadrant 1. Which trig functions are positive in the first quadrant? In quadrant 1, which trig functions are positive? We said R has to be positive in order to have a circle.
Oh, but they're all positive.
They are all positive, right?
Yeah.
Because in quadrant 1, X is positive, Y is positive. So all trig functions are positive in the first quadrant. In quadrant 2, which trig functions are positive?
Y and R.
Sine,
Sine and
cosecant.
cosecant, right? So in terms of trig function, it's going to be sine and cosecant are positive in quadrant 2. In quadrant 3, which trig functions are positive?
Are they all negative?
Nope.
Because the x and y.
Do it.
Oh, tangents.
Tangent and cotangent are positive. Because after all, a negative divided by a negative will be a positive. Okay? And lastly, in quadrant 4, which trig functions are positive?
Cosine and secant.
Cosine and secant. Okay? Are positive, right? Okay. Okay.
How are you finding out which ones are positive?
Yeah, I'm not sure exactly.
Go back to my chart we had up on the previous page.
Yeah.
Here's my chart. In the first quadrant, X and Y are both positive. Right?
And R is always positive.
And R is always positive.
Okay.
In the second quadrant, Y is positive, but X is negative. So anything involving Y and R will be positive. Sine, cosecant. Down here, quadrant 3, X is negative, Y is negative. So if I have a negative divided by a negative, I do get a positive, which is tangent and cotangent. Quadrant 4, X is positive, Y is negative. So only my functions involving X will be positive. Okay?
You said R is always positive.
Right. In order to have a circle, we said you must have a circle with a positive radius, right?
Okay.
Otherwise, you don't have a circle. Okay? Right? Okay. Right. The other thing they talk about, which really aren't used anymore, but they do talk about reference angles. And again, it goes back really to basically when I was in high school, before everybody had the toys or the apps. You used to have in the back of the trig books trig tables for sine, cosine, and tangent. Okay? And badly, they only went up to 45 degrees. And by knowing how things worked, you could then get the sine, cosine, tangent of any angle using those trig tables. Okay? But it came down to what were called reference angles. Okay? So in terms of the various quadrants, in quadrant 1, which is here, my reference angle is going to be whatever that is. Okay? It's always going to be the number in quadrant 1. In quadrant 2, so now my angle is over here. So here's my angle theta, maybe. This is theta. My reference angle is going to be this number in here. So the reference angle is always to the x-axis. So my reference angle here is going to be 180 minus theta, okay, if it's in degrees. If it's in radians, it would be pi minus theta, okay? So the first one's degrees, the second one is if the angle's in radians. Should be able to do it either way. Okay? If the angle is in the third quadrant, okay? So now my angle is down here. So here's my angle, theta. My reference angle is always to the x. So my reference angle will be that measurement. And so now my reference angle will be theta minus 180 if it's in degrees, or theta minus pi if it is in radians. Okay. And then lastly, we get to if we're in the last quadrant. So now my angle's over here. So this is theta. My reference angle is now going to be this measurement, which is there.
60 minus theta.
Yep. So my reference angle is going to be 360 minus theta, or it'll be 2 pi, depending on where they gave you theta in. Okay? So the reference angle is always to the x. Now, like I said, as far as using them to get the value of your trig functions, you don't need them anymore. Your toy can do the sine, cosine, tangent of any angle you want. Alright? So, in regards to that, on the toy, if you don't have the toy, I'll get it out. Tell me, on the toy, what is the sine of 30 degrees?
Yeah.
Alright? I want to know what is the sine of 30 degrees?
0.5.
Again, did you push the degrees key? No.
You ought to be getting 0.5. If you're not, you're in the wrong mode.
This may be a really stupid question, but
It's a sine 30.
I should make sure my calculator is functioning in radian or degrees.
Given my angle is in
Yeah.
degrees, your angle it should be in degree mode. Right? So if you do the sine of 30, you ought to be getting 0.5. If you're not getting 0.5, you're probably in the wrong mode. Okay? So when you are doing trig functions, this is one of the few times where the mode of the calculator does matter. Okay? It must match whatever your angle is in. Okay?
So if you gave me an angle in radian,
Then you got to change the toy to radian mode.
but it would be like sine
Right?
of 5 pi or something like that.
Yeah. Okay.
Well, it says that's 0.
All right. So you got that the sine of 30 degrees was 0.5. All right, now on the toy. Do this. Do the sine minus 1 of 0.5. What does that give you?
30.
30. Okay?
Crazy.
So, sine minus 1, cosine minus 1, tangent minus 1 is what you use when you want to determine the angle.
I can't type that in my calculator.
You need a new calculator.
Wait, so what is the sine of 30? Like, what does that answer represent? What is that? The
All sine, cosine, and tangent are just ratios.
there's
It's just telling you that the ratio of the opposite sides of the hypotenuse at that angle is 0.5. That's all it is. Right?
It says it here, but I don't know how to get to it.
Right? So sine minus 1, cosine minus 1, tangent minus 1 is what you use when you want to determine the angle. That's what that's for. Okay?
So sine minus 1 of 0.5 should be 30.
Yep.
I have to figure out how to do it on this thing.
So, if I have my circle, I have a point on my circle. That angle is 120 degrees. I want to know what are the coordinates of that point on my circle. Well, the way I do this, the x-coordinate will be given by r cosine theta. The y-coordinate will be given by r sine theta. So my x-coordinate will be, and let's say my radius here is going to be 10. So this is going to be 10 cosine 120. And then this one will be 10 sine 120. So 10 cosine 120.
8.66. Oh, never mind.
Never mind. 10 cosine 120 will give you what?
-5.
-5. That'll be the x. And then 10 sine 120 will be 8.66, and that will be the y coordinate of that point. So we found our point on the circle. X is our cosine theta, y is our sine. So given a triangle, right triangle, you ought to be able to find all the missing pieces of information. So for example, given something like this, I got a right triangle, call this A, B, and C. Let's say that this is 42 degrees, and this is going to be 20. So I got 3 pieces of information. I want the other 3 pieces of information. I want to know what is the measurement of angle B, what is the measurement of side B, and then what is the measurement of side C. Well, let's do the easiest thing first. What's the measurement of angle B?
48 degrees.
48 degrees. Because again, the sum of the angles in a triangle must be 180, and in a right triangle, angle A and angle B must equal 90. Right? So angle B is 48 degrees. Right? Right? So let's find, all right, what do you want to find? Side C or side B?
C.
C. All right, here's my angle. This is the opposite side. This is the hypotenuse. Opposite over hypotenuse is which trig function?
Sine.
Sine.
Yep.
So the sine of 42 is going to equal 20 over C. Right? I want to solve that for C. Well, what's the opposite of dividing? Multiplying. Okay. So we get C times the sine of 42 is going to equal 20. What's the opposite of multiplying? Divide. So C is going to be 20 divided by the sine of 42. So you plug that into the toy.
$29.88.
So let's go with 29.9.
Yep.
Right? So that's side C. So now we need to find side B, which we could do a couple ways, right? We could use Pythagorean. We know the hypotenuse, we know a way, we can find it that way. But if I did trig functions, right, we could say that the cosine of 42 is going to equal side B over our hypotenuse, which we just got, which was 29.9, right? Using our number we just found. What is the opposite of dividing? Multiplying. So B is going to be 29.9 times the cosine of 42. And that'll give us side B. Okay. And that comes out to be 22.2.
So you just took whatever trig function you had the information for?
Right.
Okay.
Yeah.
Could you do the hold on. The cosine of B though?
You could.
So the cosine of 48 and just have it be 29.9.
Well, again, you know, if you're doing relative to B to find side B, I would have to use sine. Okay? Opposite and adjacent are relative to the angle you are talking about, okay? But the hypotenuse is always the hypotenuse. That doesn't change. But opposite and adjacent are always relative to the angle you're talking about. Okay? Let's see. So we can do those. Right? Okay. So, give them a line of this. I want to know what the measurement of D is. Okay. I know this angle is 25, this is 12. I know from here to here is 300 feet. I want to find how far is it from here to there. Well, let's first break this down a bit, right? So let's say that this will be x. Right? So from here to here is x. Right? Whatever that may be. Which means then that from here to here will be 300 minus x. Okay? After all, if one part is x, the other part will be 300 minus x, right? So if I tell you that one part is 100, the other part is going to be 200. Subtract. Okay? Right? So I want to solve this for D. Well, tangent. We get that the tangent of 25 is going to equal 300 minus x over D. Tangent is opposite over adjacent. Okay? Relative to my other triangle, we got the tangent of 12 is equal to x over D. Right? 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 Got a tangent, both triangles, right? If I take this one and solve for x, what's the opposite of dividing? Multiplying. So x is going to be D times the tangent of 12. Okay? Right? Next step, substitute. I'm going to take this And now get that the tangent of 25 is going to equal 300 minus d tangent of 12 Want to solve for d? What is the opposite of dividing? So we get that d times the tangent of 25 is going to equal that. Well, on the toy, you can find the tangent of 25. Go tan 25. You got that should come out to be basically 0.466D. You can find
Is that the tangent of that's
25.
Okay.
The tangent of 12 is basically 0.213D. Well, this is now just simple algebra. Get the d's on both sides. The opposite of subtracting is to add. So we end up with
Could you scroll up for just a second?
just a second.
I thought there was an x. I thought it was tan 25 equals 300 minus x tan 12. There was never an x. Okay. Gotcha.
Okay. So this will give us whether that be 0.679D equals 300. And the last step would be divide. Okay. And we end up at 442. And that'll be easy. All right. You have one like that on your homework. That would be the process. Okay. And so in terms of this handout for today, don't worry about number 4. I actually just did number 4 on the board. That was number 4 on this handout, okay? But, so do the first 3.
I'm just gonna write it in like I did it instead. Yeah, it looks like about over 42.
All right?
Just eyeballing it.
One, and
Highlighted my
one.
guys, please.